Assalamualaikum and hi, my name is WAFFI. I'm going to present the next scheduling algorithm, which is SRT or SRTF. It is shortest remaining time first. So it is a preemptive version of shortest job first, and it is called as shortest remaining time first. So processor will be allocated to job that is closest to completion, or job that has the smallest CPU burst time. Okay, so it is preemptive if the newer job has shorter completion time. So this is the example that illustrate the concepts of varying arrival times and preemption. Okay, so we can see the process, the AT, the CPU burst time, the turnaround time, and waiting time. And this is the Gantt chart. Okay, I'm going to explain this. So we will start from at time 0. We will look at the process that is available at time 0. So from the table, we can see the AT for P1 is 0. So it will available at time 0. So because only process 1 is available, we will not going to look at the other process. So right now we will just going to execute P1, process 1, for 1 unit of time, 0 until 1. Okay, so because we executed the process 1, we will minus, or we will subtract the CPU burst time with 1, and right now we will get 7. Okay, so next we will start from at time 1. So from here, the next available process is P2. Okay, so P2 and P1 is available at time 1. So here we will start to compare the CPU burst time. So process with the most smallest CPU burst time, we will execute the process first. So right now, we can see that the burst time for P2 is smaller than P1, right? So we will execute P2. So here we will execute P2. So because if you can see here, the time for P2 is 1 until 5. It means that P2 is executed until it finished. So the reason for this is because the burst time for P2, if you look at this table, compared to the other processes, it is the smallest. So we are going to execute the process until it finish, because it is the smallest. So because of that, P2 is executed from time 1 until 5. And after that, P2 is finished, right? So we will not look at P2 after that. So P2 is finished. Then we will start from time 5. So at time 5, which process is available? So right now, because the arrival time for P4, which is the last process, is 3, the latest will arrive at time 3. So for at time 5, all processes will be available except for P2, because P2 is already finished, executed. So we will compare P1, P3, and P4. Compare the CPU burst time, which is the smallest. So as you can see, the smallest CPU burst time is P4, which is 5. So because of that, we will going to execute P4 at time 5 until it finish, because it is the smallest. So because of that, P4 is executed from 5 until 10. So P4 already finished too. And then at time 10, we'll look at P1 and P3. So the smallest CPU burst time between these two processes is P1. So that's why we will execute P1 until it finish. So P1 is already finished. So what's left is P3. So we will execute P3 until it finish, which is for 9. the CPU burst time is 9. So we will run this until it finish from 17 until 25. Okay, so right now we already done executing all the process. So to calculate the turnaround and the waiting time, so turnaround is you just look at the time at which the process finish executed totally. So for P1, it is finished at 17 here, at time 17. So that's why 17 here. We will subtract the 17 with the arrival time, the 80. So 17 subtract with 0, we will get 17. Next is P2. P2 finish executed at 5 here. So 5 subtract it with the 80. Then we will do the same with P3 and P4. So P3 it finish execute at 25. That's why 25 subtract with the 80. And then for P4 finish at time 10 and then subtract it with 83. The arrival time 3. So that's why we get this. This is the answer, the turnaround time. Then for waiting time, we can get it by we take the turnaround time and then we're going to subtract it with the CPU burst time. Okay, so this one should be 8. I'm going to erase. Okay, then sorry, take 10. Okay, so the waiting time for P1, this is the turnaround time, subtract it with the CPU burst time, we get 9. For P2, the turnaround time is 4, subtract with 4, we get 0, then 23 for P3, 23 subtract with 9, we get 14, and we will get 2 for P4. So here the average turnaround time, we can get it by just we add all the value of turnaround time for all processes, and then we're just going to divide it by the number of processes, which is 4. So we will get 12.75 milliseconds. So this is the average turnaround time. And then for the waiting time, with the same, add all this value, then divide it with the number of processes, which is 4. So we will get 6.25 milliseconds. So this is the next example. So just like before, we will look at the burst time. We will look at which processes are available at that time, and then we will compare the burst time if more than one process is available at the same time. So for this example, at time 0, job A will be available because the 80 is 0, and only this process is available. So we will execute job A for 1 unit of time, because next we will see which processes are available at the same time, and we will compare the burst time. So then at time 1, job B will be available too, because the 80 is 1. So right now we have job A and job B will be available. So we will compare the burst time. Because job B has smaller burst time than job A, then we will execute job B for 1 unit of time. Why? Why we didn't execute this process until it finished? Because there is another smaller burst time process with smaller burst time other than job B, but it is not available at time 1. Because of that, we will just execute job B for 1 unit of time, because we want to see the next available process and we will compare the burst time. Okay, where I take my pen. So burst time for job A should be 5, because we already execute job A here for 1 unit of time, and job B also should be 2. Okay, so at time 2, the next available process is job C. So we are going to compare the burst time. So right now job C has the smallest burst time. That is why we will execute job C at time 2, because it is the smallest, it is the smallest process. It is a process with smallest burst time. We will just going to execute it until it finish. So job C is execute until it finish, which is 1 unit of time. So right now job C is already finished, and then at time 3, job D will also available, because the arrival time is 3. So at time 3, job A, job B, and job D is available. So we're going to compare the burst time. Right now, which process has the most smallest burst time? It is job B, which is the burst time is 2. Okay, so job B will be execute until it finish, because it is the smallest burst time. So job B is already finished. Next, at time 5, job D and job A. So right now job D has smaller burst time, so job D will be executed. And lastly, we will execute job A. Okay, finish for this example. So it will explain more detail about how it works. Basically, it's just the same as how I explained at the previous slide. So we will move on. This is the okay, so right now it shows us the completion time. So the completion time for job A is, so we will look at at which the process finish executed. So for job A, it finished at time 14. So for job B, this is the where it finished, 5. For C is 3, and for job D is 9. Okay, next. So here we will calculate the turnaround time and the waiting time. So just like before, for turnaround time, we will take the completion time, the previous slide, completion time, and we will subtract it with the arrival time. So for job A, 14 subtract with 0 get 14, and for job B, 5 subtract with 1 get 4, then 3 subtract with 2 get 1, and for job D, 9 subtract with 3 we will get 6. And then the waiting time. So to get waiting time, we take the turnaround time, and then we subtract it with the burst time. We will get 8102. So to get the average, we will just add this value, and then for turnaround time, so we will just add the values of turnaround time for all processes, and then just divide with the number of process, which is 4. So we will get 6.25 millisecond, and for average waiting time, we will just add the waiting time values for all processes and divide it with the number of process, which is 4, and we will get 2.75 millisecond. Example 5 is a non-preemptive SJN, which means that the example 5 is a non-preemptive SJN. It is a little bit different from SRT because, as the name non-preemptive, it means that if a process is initially executed, another process will cannot preempt the initial process, even though it has a smaller CPU burst time. So you can see the table here, the process CPU burst time, the AT, and completion time. So at the not given is job A initially in the ready queue, so it runs first and continue with the rest. As I said, another process cannot preempt the initial available process. So right now at arrival time 0, process A is available, so it will be executed first. So only after process A is completely execute, another process cannot preempt job A. Next is, so you can see here, job A will be executed first because at time 0, only job A is available. So even though job B has smaller CPU burst time, we cannot preempt job A, and only after job A is completely execute, then we will see the available process. So right now the time is at time 6, process B is available, process C is available, and process D is also available. So at time 6 we have 3 process that available, and then before executing we will compare which CPU burst time is the smallest. So as you can see, job C has the smallest CPU burst time. So next we will execute job C, and after job C is completely execute, we will look at the available process again. Right now job A and job C is finished. We'll look at the next available process and compare the CPU burst time. So job B has smaller burst time, so we will execute job B until it completely executed. We will execute job D. So that how we are going to execute the process. This the job in ready queue. You can see while process A is executed, there are another process in the ready queue, and it has to wait until job A finished executed before it will preempt the uh, the process. We continue. So this is the turnaround time. Turnaround time is 69511. So to get this time, the turnaround time, we have to subtract the completion time with the arrival time. So here, this is the completion time, and we will subtract this with 86. Subtract with 0, we'll get 6. Should be 6. Then for this one, we will get 9. For job C, we'll get 5, and for job D, we will get 11. So 6, 9, 5, 11. 6, 9, 5, 11. Okay, that is the turnaround time. And for average, we will just add all this value and then divide it by 4. We will get 7.75. So that is the average turnaround time. So the comparison between example 4, we are using SRT, shortest remaining time, and example 5, we are using non-preemptive SJN. So as you can see, SRT is faster than SJN. It is 0.12% faster. Okay, so SRT. It is often used in batch environment where shortest job is given priority. Means that job with smaller CPU burst time is given priority. And then SRT, it cannot be implemented in interactive system because it will require advanced CPU time knowledge. Because in interactive system, the priority will be given to user interaction, while SRT algorithm, the priority is job with shortest time. Therefore, it will take a longer response time to complete the user task in interactive system. Okay, next, SRT involve more overhead than SJN because in SRT the system will monitor CPU time for ready queue jobs, and also it performs context switching because we have preempt. We can preempt in SRT. A process can be preempt with another process that has a smaller CPU burst time.